Okay, good morning, guys. Today we're going to look at cladistics and how we construct one of these things called a cladogram. And basically, this is just showing us how species evolve over time and split into new species, and we fit them into clades. And a clade just includes all the species that are alive today, along with the common ancestral species. So we can see where they diverged. Okay, so we're going to look at how is this constructed, how do we get to these, and what does it really show us as we go along. Okay, so a cladogram is just a tree diagram, shows similarities and differences between different species, and you've got these different points where they diverge, and this is called a node, and this is where a common ancestor is going to split in two. So what we've done to construct these is we base it on DNA sequences or the amino acid sequences. And basically, over time, mutation usually happens at like a predictable rate, so it allows us to think about how long ago these species have diverged from each other. So species has been looking at with selective natural selection. They obviously over time they diverge due to the environmental differences which cause them to evolve. So they do evolve over time. They come from a common ancestor. So we can see if we go all the way back, all of these species would evolve from this common ancestor. Now, often they don't exist because they've evolved to become new species. So at some point, they diverged to become turtles, and the rest of this branch off here came off to these here, to the lizards, snakes, the birds, non-avian dinosaurs, and crocodiles. So these have had a common ancestor, but if we go back even further, all of them would have had this common ancestor here. And some of them, the stuff that's on here, may not even be alive today. So like with humans, there were thought to be 3 species of humans at one point, and obviously we're the only ones left. Okay, so you think about like Neanderthals were around, but they're no longer about. So we can look at cladograms between humans and other primates, and we've used DNA evidence to build this. And it also gives us an idea of when they're diverged, because we can look at how often the mutations happen, look at the differences between the base sequences. 30 years ago, like down the side here, we can have a look at millions of years ago. So we had an ancestral primate around about 55 million years ago, would have diverged off to make the lemurs and stuff over this side. And then as time moved on, you can see how we've like diverged, and humans diverged from like, well, monkeys and chimpanzees and humans diverged off around about 5 million years ago from each other. So these are all, it just gives us an idea of what our common ancestors were and how long we've been diverging from. So it's all gone from like mutations in DNA that persist and inherited at a heritable rate. So it's kind of like a molecular clock to give us an idea how long they diverged. If we've got a very similar base sequence, then they haven't been diverged for very long. If you've got a huge difference between the base sequences, then they diverged ages ago. So it gives us an idea of how long ago they diverged. So it gives us an idea of like what species are closely related to each other. And you could have questions like, you've got to be able to do analysis of cladograms to reduce the evolutionary relationships. So if we look on here, it says which animal is most related to the squirrel. So if we have a look, we can see over here we've got squirrel. You can see they had a common ancestor, and on the other side it's a guinea pig. So obviously this one is going to be guinea pig. Okay, which animal is most related to humans than old world monkey? It should be than rather than that. So again, we come over to here. We've got old world monkeys here. Humans are here. Which ones are humans more closely related to? You should be able to come up with any of these answers here. So you could have gibbons, orangutan, gorilla, bonobo, or the common chimpanzee. So any one of those would be a fine one. Tarsiers show a common ancestor with which animal? So again, we've got to come over here, find them, and then we think about what common ancestor they had, and then we can go with the answers that come off the rest of there. So you could say that we've got the New World monkeys, you could say the Old World monkeys, and then all the rest down the end here. We had a common ancestor there. Elephant shrews, elephant manatee, and dugong all share a common ancestor. Which animal diverged from the ancestor first? So we need to find the elephants. It's really weird to think elephants and manatee were really closely related. If you look at them, it kind of looks a bit weird, but obviously by looking at the DNA structure, we can see that they haven't diverged for very long. Which animal diverged from the ancestor first? If we look there, it's going to be the elephant shrew that diverged a long time ago. Well, not a long time ago, but diverged first, and then these two branched off later on. So hopefully that makes sense to you there. Okay, so we used to use, sometimes we use homologous structures to give us an idea of animals. So if you look at, like, obviously humans and chimpanzees, they look kind of similar, and they would have homologous structures that are common because of common ancestry. Analogous structures are similar because of convergent evolution, which just means that things have evolved independently of each other. So, like, if you look at a human eye and octopus eye, they're very similar, but obviously we're not like that close related to octopus. So they've arrived. It's just both species have arrived at the same answer to the same problems. They've evolved independently. They've evolved to have that same structure, but it's just something similar. They've arrived at the same thing. Where homologous structures are similar because of common ancestry. Analogous structures are ones that have, it's just the same solution to, like, a different problem kind of thing. So that's how they've evolved. So what we used to classify things by looking at appearance, but obviously over time it's led to looking at DNA, which is probably more reliable. It cast out on traditionally classified groups, which meant we had to reclassify things. So, like here, reclassification of figure word family using evidence from cladistics. And there's a nice data question you can answer in your textbook. So if you go to your textbook, I think there's some questions in there on page 275 that you can answer about that. But they're basically, from this is an example of where we've got convergent evolution. They've evolved many times from different ancestors, but they've arrived to similar they've had adapted to similar pollinators. So they're probably trying to be competing for the same kind of like insect. So they've adopted similar, like, flowers to get the insects to come to them, but they've also adopted a similar seed dispersal strategy. So it looks like they're very similar, but when we look at the DNA, they're actually it's actually different. So that's led to a reclassification, and that's how that would be used. So what I want you to do now is I want you to review the stuff in the PowerPoint, make sure you understand it. I don't think it's any complicated than 5.3. I think this one's probably quite easy. Just go through, update your notes, and then just do the Bionology 5.4 quick quiz. I'll get you the answers to these next week. We can go through these, make sure we understand these. So let's just go through these questions, and then once you've finished that, what I'd like you to do is go back over everything in 5.1, 5.2, 5.3, 5.4. I'll put a document on Google Classroom, and I'd just like you to put down some of the stuff that you just want me to go back over, and we'll have like a review lesson at the beginning of next week, because there's a lot of stuff in there. We've gone through it probably at breakneck speed, and there's probably some stuff that you probably just need clarifying. So if you can just add your name or add a question to the document I'll put into Google Classroom, I'd really appreciate that. Thank you. Cheerio. Bye.